Well, here you can actually see where after 20 years of serving to keep the water out and function properly, these shingles were busted loose by a wind event on the same slope and slid down and collected in the gutter down there. And you'll notice that there are multiple sections here. There's one here, one over here, one here, two down there. This is all on the same slope. This is not a mechanical issue. This isn't an installation issue. These things performed fine for about the 20 years this roof has existed. But then, due to a wind event, not only do we see some of these shingles being creased and fibers broken, pieces from the hips and ridge being blown off, shingles being lifted and sediment deposited, but you also see where some of these shingles were just lifted due to the wind, and some of them blew off, and some of them just slid down into the gutter. This is pretty widespread on the whole roof. Here you can actually see, again, some more shingles that are missing due to the wind event. Out of breath here, climbing all over this. You can actually see where one of the cap shingles was busted loose and blew off recently. You can tell this is recent because the thermal bond is still somewhat intact, and the coloring, you can tell this part hasn't been weathered. So here's a missing cap shingle, and you can again see those fibers bleeding through. It's just not repairable. More fibers. That's actually a impact to the shingle. That could be from windblown debris or hail, anything like that. But that right there is an impact and puncture. Do you see that? That's actually a puncture to the shingle. And this is, again, all throughout the roof. You're going to see these punctures. And then we got an actual missing shingle here on a old non-repairable. I'll keep looking. Now here on another section of the roof, you can see, again, more problems here. The whole shingle has been unsealed and lifted by wind-driven rain or just strong winds. And as a result, that thermal bond here has been broken. There is sediment underneath here. Like, I can run my fingers. You see that yellow sediment right there? That right there is actually coating that thermal bond so that it'll never reseal. So this shingle has suffered a direct physical loss from a wind event. We know that deposited debris and particulate that I just showed you, that doesn't get there just by water running down. You have to have a strong wind force driving it and depositing it under here. So we know that the wind is what broke this shingle loose and left that debris underneath. And you can see this whole shingle here is loose. It kind of loosened this corner and this corner as well. See, this one's actually bonded. This one's loose. These aren't nearly as bad, but this one is completely shot. And so as you got more wind events that come in, it's just going to continue to spread all through that whole roof system. And we're seeing this all over the entirety of the roof. This isn't just a broken seal due to age, but as I showed you, I pulled out that, see that debris underneath there? That's coated the thermal bond. That will never reseal. That only occurs due to a wind event. That's not just an age issue, but that is direct physical loss due to a wind event. All right, here's an entire course of shingles right here, an entire shingle that the wind again got under, deposited that sediment underneath. There's actually some degradation in the asphaltic mat. Right here you can see where it's starting to crease. The fibers, like the fiberglass I just showed you in that last video, the shiny bits, that is like the skeletal system for your roof. And that's where the reinforcement is. When that breaks, that's like having a broken bone. When you start to see this kind of creasing at the top, that's kind of like the bone starting to stick out of the leg, so to speak. I know that's a rough metaphor. But basically, the wind got under this shingle, broke it loose, it goes all the way down. None of this is bonded. There's sediment deposited underneath. The fibers in the shingle are starting to crack, and there's creasing in the asphaltic mat that's starting to appear. Just as I ran my finger across that, you saw some granules come loose. Now, down here, this is at the butt edge of the shingle, and you can see that not only is this course loose, but then also on these where they kind of meet. There's looseness here, and this is just the weakest part of the roof. It's the corner of the shingle. It's the easiest part for the wind to get underneath of it. But this one, again, more sediment underneath of the shingle. It will never rebond. It'll never reseal because that thermal bond underneath of here has been broken and coated with stuff like dirt and dust and small vegetation and pollen, and that has prevented this from ever resealing. It will never reseal. I don't want to lift on it too much because I don't want to exacerbate the problem or damage it, but I do need to at least put hands on it so you can see what we're talking about here. A little out of breath. Nice steep roof to climb on. You can see all of the shiny parts of the roof. That is the fiberglass mat that is being exposed. This roof is at least 20 years old, and consequently, it is far too advanced in age to perform a spot repair. If we tried to pop out one damaged shingle, we have to remove the fasteners 2 courses above for every one shingle we're going to pull loose, and then we have to lift the shingles 90 degrees perpendicular to the roof deck. That's according to Underwriter Laboratories, so that we can get the nail head flush against the decking. Otherwise, if we do like a 40 or 45 degree, we're driving the nail in at an angle, and that nail head would then cut through the shingle. Now, if we actually do a spot repair on this roof, given the poor condition of the roof with the brittleness of it, the advanced age, the non-repairable nature of this, we would actually crumble these shingles and cause more damage. It would lead to cascading failure of the whole roof system. There's not a way to come in here and do a spot repair just simply because if we pull out one shingle, we're going to damage the ones above it or next to it. And so it just leads to a full widespread replacement of that slope. And as you can see, this roof has tons of valley tie-ins. So if we're going to replace the slope here, it actually ties in down here, which means we have to carry it over to that slope. Or if we're going to do a repair or replacement on this slope, because it's non-repairable, we do that whole slope, but it ties into this slope. And so as a result, now we have to replace that whole slope. And so given the damages here, there's not really a way to do a spot repair. The shingles just simply are not pliable enough or healthy enough to do that. And you wouldn't even be able to come in and just do one slope. You would have to do the slope and the connecting slopes. So once you factor all of this in, you're looking at, goodness, easy, what, 70, 80% of the roof, I would imagine.